Hello students, in this session I am going to take elements of quantum chemistry, in which we are going to discuss the rules for filling up electrons in various orbitals. The first rule is Hoffu principle, second one is Pauli's exclusion principle, third one is Ohm's rule of maximum multiplicity, and the last rule is N plus L rule. Let us discuss rules for filling up electrons in various orbitals. Hoffu principle. This principle states that in the ground state of an atom, electrons fill atomic orbitals of the lowest available energy levels before occupying higher levels. That means you have to fill the lowest energy level first and then higher energy levels. That means we have to start from lower to higher energy level. In German, the word Aufbau means to building up. The various orbitals in order of increasing energy are arranged as follows. That is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 6s, 4f, 5d, 6p, 7s, 5f, 6d. See the sequence of the filling of the various orbitals. First we have to write the orbitals like this: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, and the last one is 7s. Let us start the filling up of the orbitals, starting from 1s orbital, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, like this. Let us go for the Pauli's exclusion principle. This principle states that no two electrons in an atom can have all the four quantum numbers same. This implies that an orbital can accommodate a maximum of two electrons with opposite spins. This is because the n, l and m values for the two electrons in an orbital are same, so they must have spin quantum numbers plus of and minus of. Each electron in a given atom has a unique set of four quantum numbers, and all other electrons in that atom are excluded from having the same set of quantum numbers. Let us go for the Ohm's rule of maximum multiplicity. In the ground state electronic configuration of an atom, no electron pairing takes place in the degenerate orbitals belonging to the same subshell until all the orbitals of the given subshell are singly occupied with parallel spins. That means no pairing of electron takes place until all the available orbitals can have one electron each. That means when all the orbitals can occupied by one electron, then only the pairing takes place. In case of carbon, the differentiating electron enters the second unoccupied orbital of 2p. Instead of getting paired up in the 2p orbital, which already occupied with an electron. So, the electronic configuration of carbon is helium 2s2, 2px1, 2py1 and not helium 2s2, 2p2. Similarly, the electronic configuration of nitrogen is helium 2s2, 2p1, 2py1, 2pz1. That means helium within the bracket. Then we have to write 2s2, 2px1, 2py1, 2pz1. Let us go for the last rule, n plus L rule. The relative energies between any two orbitals can be determined by this rule. According to this rule, if two orbitals have different n plus L values, then that orbital with lower n plus L values is of lower energy. For example, 4s orbital has n plus L value 4. In 3d orbital has n plus L value 5. Therefore, 4s orbital fills before 3d because 4s has a lower value of 4 and 3d orbital has higher value of 5. Therefore, we have to fill 4s, then 3d orbital. Similarly, if two orbitals have same n plus L value, then that orbital with lower n value is of lower energy. For example, if 3d orbital has n plus L value 5 and 4p orbital has n plus value 5, but n value of 3d is less than 4p and hence 3d orbital fills before 4. Thank you.